Hello everyone, welcome back to the channel. So uh, today I was solving this question called the assembly via minimums from the TLE Eliminators CP sheet from this 1200 rating category. I didn't plan to upload the solution for this problem, but I thought my method to solve this problem is pretty interesting. So I thought I should share a solution with you. So let's take a look. So this is the problem. Sasha has an array A of n integers. Okay, so first of all, I recommend you to try this problem on your own. Try to come up with the solution. And uh, yes, so that's the thing. And if you understood the problem statement thoroughly, you can directly skip to the solution part of the video. So here we go. Sasha has an array A of n integers. He got bored and for all I comma j, I less than j, he wrote down the minimum value of ai comma aj. He obtained a new array B of size n into n minus 1 by 2. So for example, this is the thing, this is self-explanatory, and then he randomly shuffled all the elements of the array B. Unfortunately, he forgot the array A, and your task is to restore any possible array A from which the array B could have been obtained. Okay, so and the elements of array A should be in this range. Okay, makes sense. So the first line of each test case will be like they will give n, and in second line they will give n into n minus 1 by 2 integers. That's pretty standard input format. And yep, we have to output the possible array A from which we can obtain we could have obtained, or we have obtained array B. Okay, so let us take a look at this sample test case. Okay, so uh, so I have to ensure that my array A will have 4 elements, right? So by seeing here, so I have three times, right? So frequency of 3 is 3, 5 is 2, and 7 is 1. So this is element and this is frequency. So from here I can observe that my array will be something like 3, 3, okay, 2, and okay, not 3 actually. So it will be 3, and so suppose 3 should come 3 times, right? So there should be 3 such pairs that minimum of them is 3. Okay, so I can write some elements, 3 elements here, such that they all are bigger than 3. Okay, so one more thing to notice, that 7 is appearing once. Okay, so 7 is appearing once means, so there is 7 in the array and there is one more element 11 that is greater than or equal to 7, right? So this will be the maximum element of our array A, right? So let us keep it here, that element, right? Let's call it big E, and here it will be 7, right? And we know that element should be greater than or equal to 7, and here it should be 5. Okay, make sense? Yes, so here element E is some number greater than or equal to 7. For this case, let's take E as 7. Okay, makes sense. And this is basically our array A 3577. Okay, and for another test case, let us take a look at the test case number 4. So here you notice that you have 5 into 4 minus 1. 5 into 5 minus 1. Okay. So here we have 5 into 5 minus 1 by 2, which is 10. 10 twos, right? So here we can notice that we will have all the twos in the array, right? We can have all the twos in the array, right? So that is the thing. And I think we can also have element greater than or equal to 2 here, right? So we can basically have element greater than or equal to 2 here. That's the thing. And so that is basically the problem. And here let me explain this test case as well. So to get a grasp of my solution, you must understand how the sample test cases are working. Okay, so here we can have like this is the element and this is the frequency. So minus 2 is appearing 4 times, 0 is appearing 5 times, and 3 is appearing 1 times. So here they have given that array as this thing. Okay, so here we can notice that, so for this 0, these 4 elements, okay, not these 4, actually these 3 elements will give you 0, and for this 0, these 2 elements will give you 0. So frequency of 0 would be 5. For this minus 2, all the elements will give you minus 2 from that pair. So frequency of minus 2 is 4, we can see here. And for 3, only 5 comma 3, this pair 3 comma 5. I'm not talking about the indices, I'm just talking about the absolute values here. So 3 comma 5, so this will give you 3, and 3's frequency is 1 here. Okay, so that's the thing. Now what my solution does is that, so my solution, so let us sort our array B. Not actually sort, okay, let's sort it. Sort array B and store the frequency of each element from array B, right? So frequency of, we will store it in a map, right? Map of long long comma long long, where first argument will be the element from array B and second argument will be its frequency of each element in array B. Perfect. So suppose you have sorted array B. Okay, so let us take a look at this sample test case. So okay, so here our map will be for 3 you have 3, this is element, this is frequency, 3 5 comma 2 and 7 comma 1. Okay, yes, makes sense. And now what will I do is that, so I know that there will be element in array A, so I have to construct array A. This is a constructive type of problem, and they are actually very interesting problems. So interesting and hard to solve as well, in my opinion. Not hard, but enjoying to solve. Okay, so uh, as I know that 3 is appearing in B, there must be a place in array A where 3 will be appearing, right? So what I will do is that, so let's go down. Okay, not actually, let's stay here and let's take this down. So what I am saying is that, so I don't know how much times will 3 be appearing an array A, right? So I don't know if it is I just know that it will be appearing. I don't know the frequency of that element in array A. So let me suppose that it appears k times in the array. So let me suppose this is the most important part of the solution. So carefully listen. So I will choose k, that k is the frequency of element, this 3 element in actual array A, right? So then suppose I'm checking for this minimum element right now. So there will be n minus k other elements. Okay, so see here. So suppose these k are occupied by that element el or el. Okay, so and all the other elements, as this is the minimum element, all the n minus k elements, so they will form pair with these elements, right? So how many number of pairs will be there? K into n minus k. That's the basic combinatorics. So and principle, and plus. So plus, why plus? Because the pairs within these elements, so how many pairs will be there in these elements? Like k, choose 2, right? K, C stand for choose, and KC2, because that's again the basic combinatorics. And this should be my frequency here, my frequency right here in the map, right? So let us call it appearance. How many times is it appearing in array A? Okay, makes sense. Yes, so let me erase this. I hope it's clear. Okay, so remember that we are doing this for the minimum element right now. Okay, so let us solve this quadratic equation. So I know n, I know a, so basically it will be like k into n minus k plus k into k minus 1 by 2, this is k choose 2 is equal to a, then 2k into n minus 2k square plus k square minus k is equal to 2 times a. Okay, just multiplying by 2. Okay, so no need of this guy. Okay, so here it will be like k into 2n minus 1, k into 2n minus 1, grouping these two terms, then minus k square is equal to 2a, then it will be k square minus 2n minus 1 into k plus 2a is equal to 0. And from here you will get two values of from the quadratic equation. Okay, k will be 2n minus 1 plus minus root over 2n minus 1 square minus 4ac, which will be 8a divided by 2. Okay, so here's the thing, and you know n, right? You know n, you know a, right? You know both of those values, right? So basically n will be given. You can calculate number of appearance of that element in array B. So you can calculate the value of k, right? You can calculate the value of k, and that is the most important part in the solution, right? So you want to calculate how many times that element, every element that is in B is appearing in A, right? So how many times that element is appearing in A, so that's the point. And basically there will be some places where your k will be greater than n, right? So for suppose in this case, in this minimum, suppose when the element is minimum, when your n k is greater than n, then how can you assign k places when there are only n places in the array, right? So you will reject the greater value of k. Let k1 be the greater value of k. It can be equal also when these two terms cancel out, but yep, k1 is greater than or equal to k2. And when k is greater than n, we will just overthrow this value k1 and we will choose k2. And we definitely know, we for sure know that k2 will fit in the limits, right? So k2 will be greater than 1 and k2 will be less than n. For sure we know that. Why? Because they have given that it is guaranteed that there exists an original array, right? So it is guaranteed that this is the constraints, and for each array b in the test there exists an original array. That's the important part of the solution. Okay, so that's basically the thing. So k2 will always work if k1 doesn't work. Okay, so you are sorted with this element. Okay, sorted means done. Okay, so let me use that done word. Okay, so you are done with this minimum element. Okay, so now you will hop on to the next minimum element, which is 5, and you will try to again solve this quadratic equation and output how many times 5 is there. But do you notice here is that, so here it will be not n minus k anymore. Here, take a look, ladies and gentlemen. So here it won't be n minus k, because you have outputted some elements. Some number of 3, some number of this elements, right? Some number of 3, so that your array size has shrinked, right? What array size? Array size of a, actual array a, because there will be, suppose this is the array a and you assign two positions to 3, and now you have to calculate for 5. So you won't be having n minus k elements for 5, right? So here we had n minus k elements for 5, 3, sorry, n minus k elements for 3, but here in case of 5 it won't be the case. It will be n minus k minus number of positions taken, from array a. That is the whole thing. Okay, so here you have to keep one more variable called out, which is the number of outputted elements till now, and here there's a one small modification. So here it will be n minus k minus out. Okay, I hope this is visible. So here I have modified it. It will be n minus k minus out. Okay, so that is the thing, and accordingly these all solving steps will also be changed. Make sense? Yes. So you try to calculate what will be the original equation for k then. So let me directly give it to you. So it is basically k is equal to, okay, where have I calculated it? Okay, so k is equal to n minus out plus 1 plus minus root over n minus out minus 1. Okay, wait. So, okay, I messed up. So not this thing. So wait, I'll solve it and write it. So yes, I'm done. So I'm done with the calculating value of k. Okay, so these are the steps involved, and your final value of k is this. Okay, so this thing. Okay, so there will be two values. there will be two values, k1 and k2. Okay, and k1 will be greater than or equal to k2. So we will always try to fill the maximum possible elements that we can fill. Okay, so maximum possible elements that we can fill, and if we cannot fill them, we will try alternate path. Okay, so make sense? Yes. And after outputting, suppose I output k1 elements in this iteration, then I will do out plus is equal, oh, what am I doing? Out plus is equal to k1. Okay, and if I don't output k1 elements, if I don't output k1 elements and I output k2 elements, so out plus is equal to, so not k2 elements actually, element k2 times. Okay, element k2 times, so out plus is equal to k2, and you'll go for the next iteration. So that is basically the whole solution. Let's take a look at the code. So code is pretty straightforward to understand. So here is the input, taking the input, and here we are calculating elements frequencies and initializing variable out as told in the solution. So these are some debugging steps I have added. And A is appearances, right? Appearances is the frequency I have told you, and QB is our, okay, what are QB, QB, QC, QB, QC, QA. So QB, QC and QA, they are basically like, this is the standard form of the quadratic equations, and this is the solution for that quadratic equation. Okay, so and I'm giving variable names QA for A, QB for B, and QC for C to substitute in this formula. Okay, nothing more fancy here. Okay, so forward. So yes, that's the thing, assigning QA, QB and QC to the corresponding values. Here you can see that your QB is negative of this value, your QA is 1 and your QC is 2A. Okay, and I am calculating K1, and if I can output if I can output K1 like element K1 times, then I will output it, and I will increment this output out variable with K1. And if I cannot, then I will calculate K2, and I can definitely output it, that element K2 times, and I will add K2 to our output out variable. Okay, so and I will do this for every element, in every distinct element in our array B. And finally, yes, a nice little beautiful end line. Okay, not end line, okay, new line, or whatever you want to say. Yes, and that's basically the whole solution of the problem. I hope you were able to solve this problem on your own, and if you didn't, I told the solution anyways. So I hope you enjoyed solving the problem and listening to the solution as well. And thank you for watching, and we are now community of greater than 100 members on our YouTube channel. And thank you for the support you have shown till and will show further. Thank you again. And yes, so if you like this, if you learned anything new from this video, consider liking the video and staying tuned, staying subscribed to our channel. And yep, thank you again. See you again.